Hello, everyone. I thought we could go over a little bit of how to solve for logs and understanding some basics between exponentials and logs. So starting off, an exponential, and I'm going to abbreviate. An exponential is a base to some power. So if I said 3 squared, 3 would be the base, and 2 would be the exponent, or some professors may call it power, either way. And then logs are functions. A log, there are two basic ones. One that is called a common log. You don't need to memorize that. But a common log is written as log base 10. That's the little subset of another item. Now, on our calculators, our logs are already put in base 10. And so you'll see it also written as log of x. Now, if you think about writing a variable, say y, x, w, whatever, and there's one of them, do I need to put the one in front of the x? No. We already know that and understand if there's no number in front of the variable, then it's automatically a 1. So if I have a log of something, it's automatically a base 10. The other item is a natural log, and that's when the base is e. Now, e is a number, just like pi is a number, and it has a symbol. E is 2.718, and it goes on and on and on, just like pi does. Now, this one can be rewritten as natural log, that's ln of x. So if you see log base e is ln. They're exactly the same. Now, as a review, remember that in operations, meaning if you're adding something, what undoes addition? Subtraction. What undoes multiplication? Division. Well, what undoes exponentials? Logs. And then logs undo exponentials. So there's several methods to solve. I'll write that. I'm going to give you a couple of them, about 4. Sometimes it's easier to use one method versus another. Let's take an example, and I'll use it throughout. 2 to the x plus 2 equals 8. So my first method, method 1, I'll call it, is where I make the bases the same, if I can. This is my favorite. If I can turn in this item, this is a base to an exponent. Can I make 8 the same base as 2? Well, what's 8? 8 is the same as 2 times 2 times 2. Well, that can be rewritten as 2 to the third. So I can make 8 the same base. And I would substitute this item in 2 to the third where 8 is and solve. So I have 2x plus 2 equals 2 to the third. Now we use this thing called identity property. Do you need to memorize this? No. But identity property says if I have a base to some exponent, let's say it's u, and it's equal to the same base to a different exponent, say v, but the bases are the same, then I can set the exponents equal to each other and the bases are gone. And I can do that here. This is why it's my favorite. So the exponent comes down, exponent comes down. I have x plus 2 equals 3, and x equals then 1, because I would subtract 2 to the other side. This is truly my favorite if I can make it happen. What about method 2? Well, method 2, what it does, it uses the definition of logs. Use the definition of logarithms, or I shorten it, definition of logs. And what I would do is, here's the same example. We're just going to use the same one throughout. what is the base? I always ask myself, if there's no log in there and it's an exponential, what's the base? The base is 2. I think about a scorpion. Can I make a scorpion? Here's the head, goes around, finishes at the exponent. I think about that as a tail. Well, can I change that into a log? Absolutely. Remember our format of a log, it goes log and then a base of something. Well, I would write this log, and I would start with the first number. That's the base. So this is the base of 2. That's a little subset. And then I follow my tail. The next thing that comes in order is 8. And then it has to equal x plus 2. It's just a little shortcut I think about a scorpion when I do these. And then let's solve. Well, as a reminder, not all calculators allow you to put this in. For example, on the TI-30X, it doesn't have a button where you can choose the base. It only has log base 10. So I can change this to have the same base. And how I do that is make this log base 10. I don't need to put the 10 there if it's a 10 of the big number on top of 8. And then log base 10 of 2. So those just get split into 2 with the log having the base of 10. And then I would go, all right, how do I solve this? I don't like to put it in the calculator yet. I would subtract 2 to the other side, and then all I have to do is plug it into the calculator. If you have a calculator that allows you to put in the base, then great. But if you don't, this is how you would do it. You would have log base 8 divided by log base 2, and then subtract 2. This one allows you not to have to put in that extra parenthesis. I get 1. Or you could do log base 8, do it in pieces, divided by log base 10, of 2. I misspoke on the first little piece. Hit enter, I get 3, and then I subtract 2. Order of operations says I do parentheses, then multiplication, division, and add and subtract last. And my answer again is 1, and that's exactly what we had in method 1. Now we have 2 other ones, because not always will you be able to use method 1. We need some ways to do other items. So here's another one as a review. I call it method 3. And this is where you can take the log base of both sides. So let's take that example again. 2x plus 2 equals 8. And I'm going to take the log base. Well, this base has to be the exact same base as the base of the exponential. Here's my base of my exponential. So I would have log base 2, and then I still have 2x plus 2 up here, equals log base 2 of 8. I'm just adding the log base 2 on both sides. Whatever I do to one side, I can do to the other as long as I keep it equal, and it keeps the equations equivalent. Now remember, I said at the beginning that what undoes an exponential? A log. Do I have the bases the same? Yes. As long as the log base is the same as the base of the exponential, they undo each other. So those would be gone. And this item in the exponent drops down. So I would have x plus 2 still equal to log base 2 of 8. Now, we can split that depending on your calculator. If you have a calculator that allows you to put in whatever base you want, then you have it done. But I have log 8 over log 2, and the bases are 10, subtract 2, and again, we're back to what the previous method had, and then this ends up being 1. So exactly like before. Then the last option, and again, these are just options based on your problem, is method 4. And instead of taking the common log, I can take the natural log, the ln of both sides. So how do I do that? Well, let's do it. So we have 2x plus 2 equals 8. That's my example. And then I say, oh, I'm going to take the natural log. Remember, natural log is log base e. When you do that, that's an operation. Remember, logs are operations. Then you can take this group in the exponent, and they can come around. That's the expansion of logs, which you should have had prior to this class. So this is x plus 2 times natural log 2. Natural log of something is an operation. They go together. Well, I need to solve for x. Well, these are multiplying. I can do the opposite of multiplying. It's division of the piece I don't want. So that's natural log 2 is gone. And then I'm back to x plus 2 equals natural log 8 over natural log 2. Subtract 2 to the other side. Plug it into your calculator, and you will get the same answer of 1. So those are 4 methods, just as a review for anyone who needed that, of how to solve logarithmic equations. Hope you have a great day.